Yeah.
That roll sheet going around somewhere? The roll sheet somewhere, way up. There. Just an FYI, this is the Friday of spring break. I mean, the Friday, not the Friday of spring break, the Friday of finals week. If you want to get the heck out of town, this is a direct flight. They're now flying directly out of Eau Claire, Wisconsin into Orlando, Florida, $75. So at 4:30 p.m. on the Friday of finals week, if you want to get out of here, $75. Can't go wrong with that. So that's on Sun Country, direct flights out of Eau Claire, Wisconsin. I booked that last night because my father lives down there and I go down and he's in the hospital right now. His health has not been good. So I'll go down and take care of him for a bit. So $75. Okay. The last Zoom, I didn't have video. I don't get it. So we'll try again. But there are videos out there in YouTube anyway. It's pretty much the same. All right, we're going to get through enough today to, because OWL Chapter 2 Part 1 is due Sunday night. So we'll get there. So what I want to do is I'm going to throw down these answers as quick as I can. We're going to switch over to the other learning guide, finish up that, then we're going to come back to this. So hopefully you have done this column. And hopefully it's looking just like this. Now, the answers are out there in Canvas. So you can grab this out there in Canvas. So I just did that column. Hopefully you've maybe looked at this out in Canvas land, and that first page hopefully went quickly. Now I'm going to turn over to page 6. So you can look at this. The answers are posted in Canvas. Okay, on page 6, this will do a little bit of review, and this will get us to chapter 2, part 1 of OWL. So if we look at this on page 6, it actually says in class review. So let's look at this. We want a noble gas in the same period as germanium. Come on, what's going on here? Group 18 is our noble gases. Okay, I'm at the top of page 6. Noble gases, we're in group 18 column. Again, I'm going to use 18. Remember, when you do your OWL, this B and A stuff is going to be mixed up. Double check what OWL is using, and just take your periodic table and change it to the OWL numbers, right? I think it does. OWL does B here, doesn't it? I think it does B, but anyway, fix up this table. So germanium is right here. So if we want a noble gas in the same period as germanium, we're talking about this row, we go over here, noble gas, we're talking about krypton here. The alkaline earth metal in the same period as selenium, alkaline earth metal is group 2. So we're going to be in group 2. We're going to intersect group 2. Same period as selenium. Now selenium's way over here. So I'm going to stay in this period, come over until I get to my alkaline earth metal calcium. Alkaline earth metal is going to be in group 2. So we should have calcium here. The halogen in the same period as lithium. Halogen is in group 17. So group 17, halogen here, same as lithium. So lithium's right here, the same period as lithium, come across until I get to fluorine, right? Until I get to fluorine. Okay, down here, what do we got? We got an alkaline metal. We should be in group 1 for an alkaline metal. It has 11 protons. We should be able to look that up. 11 protons, mass number of 23. Alkaline metal, this should be sodium. 11 and 23. Noble gas is going to be in group 18. 75 neutrons, 54 electrons in the neutral atom. So 54 electrons and 54 protons for a neutral atom. So 54, we're talking about xenon, right? Talking about xenon. So for this, we would have Xe, 54, and my mass number is going to be 75 neutrons, 54 protons, 129. 33 protons. Next one, 33 protons is going to be arsenic. 33 protons. And 40 neutrons. So we've got 3373. And the last one, alkaline earth metals. So we're in group 2 again. 88 electrons or protons. 88 is going to give us radium here. 88. So we've got $88 and then 126, huh? Or 226, isn't it? 226, 226. Okay. A little bit more to review, and we'll look at this because this is what Al does. So a compound that contains ion is held together by ionic bonds is called an ionic compound. These compounds usually contain a metal ion. Start with a metal ion. An example is table salt that has the formula sodium chloride. For ions, see the pink sheet, when atoms share rather than transfer electrons, gain or lose electrons, you form a covalent compound. That should be red. Fix that. That contains covalent bonds. Carbon dioxide is an example. So you've got two nonmetals together, covalent compounds. We use these prefixes, right? Mono, di, tri, and so on. These right here are covalent compounds. These are all nonmetals. So Al has you do some of this in this section, and you have a molecular formula. And that just combines all of the atoms. The molecular formula combines all of the atoms. You have a condensed formula. From this condensed formula, you can figure out the structural formula. So this carbon right here is this one. That's my CH3. This carbon has these 3 hydrogens attached. Then this is my second carbon. And that carbon has these 2 hydrogens attached. It has this oxygen attached, and the oxygen has a hydrogen. So it has you do a little bit of this. I think I grabbed this directly from the textbook, but Al has you match up some of this. And a lot of times it's a structural formula going to the molecular formula. So if that's the case, you should be able to just count everything up, right? And you might just, there's all of my hydrogens. So there is my 6 hydrogens. There's my 6 hydrogens right there. I've got 2 carbons and an oxygen. I think a lot of it is like this. I got an example on the next page. I think, no, that's not on page yet. All right, let's go to the next page here. These ions right here, these are the ones that you want to put into long-term memory. These should be the same ones that we've highlighted here. So these are the ones that I've been instructed for you to suggest to put into memory. This table here should match what I highlighted here. So these are what we're going to work with today. These are polyatomic ions right here. What are polyatomic ions? Two or more ions covalently bonded together. They stay together. And we'll talk about that as we transition over to the next. But here, I'm sure you've heard of nitrite or nitrate phosphate. These are what we are going to deal with coming up. Okay, molecular models. Now, molecular formulas, this is kind of the color convention. So if we go to the next page, this looks to be an OWL question. Very, very similar to an OWL question. So the first thing I might do with this is count up my hydrogens. So if I highlight my hydrogens, where I got 7 hydrogens, well, there's only one answer to that 7 hydrogens, I'm done. All right, there's only one that has 7 hydrogens, should be this right here already. So I'm pretty sure you've got an OWL questions that match up like this. All right. We covered ions here. Let's turn the page. We did previously look at this chart. But I want to talk about this chart just for a little bit here. Noble gases, no ions. We do not make any compounds out of noble gases. We're not going to make neon chloride, neon nitrate, anything like that. These noble gases are stable. They don't want to do anything with their electrons. They don't want to give up any electrons. They don't want to take any more electrons. So you will not see us write any compounds with the noble gases. Everything in group 17 has a -1 charge. How does it do that? Gain 1 electron, right? Everything here, -2, gain 2 electrons. How do we get a -3? Of course, we would gain 3 electrons. Now, notice all of my negatives over here, nonmetals. In the middle here, I have my metals that can do, depending upon what it reacts with, it can give up multiple electrons. But everything in group 1, this actually includes hydrogen as well. Everything in group 1, +1 charge, lost 1 electron, right? Everything in group 2, lost 2 electrons. Okay. On the next page, we don't calculate any Coulomb's law, but properties of ionic compounds. Now, what are ionic compounds? You've got a metal atom that's going to form an ion. So we're going to have a positive ion and a negative ion. These are attracted to each other by electrostatic forces. So this is making lithium fluoride. Lithium giving up 1 electron, fluorine taking on 1 electron to become fluoride. Obviously, there is a distance between their nuclei. So they represent that as the distance. Now, the force, and we're not calculating this, all we have to do, we know this. I need to make this like a lot bigger. If you just look at the equation, the force depends directly on the charges. So let's talk about that first. So if we have this, we just have a +1 and a -1 charge versus aluminum, which is +3, sulfide is -2. Without calculating this out and getting too complicated now, we have a plus charge. We have a minus charge. The larger the charges, the more the force in the numerator, right? This is going to have more attractive force because we got a +3 and a -2. Okay, don't overthink more than that. Luckily, we're not calculating this. We don't want to calculate this. This has more force in the numerator just because the charges are more. And I'll just have you pick out which one has the more force, I believe. Then you would also agree that, so it's directly proportional to the charges and inversely proportional from the distance between them. As this kind of like density, mass over volume, as the volume gets less and less and less in the denominator, the density gets higher and higher and higher. If the distance here is less and less and less, the force would be higher, correct? If they're closer together. Okay, that is all there is for you to get through OWL chapter 2, part 2. We're going to finish writing formulas of compounds. And next time after formulas, so we're going to finish up formulas of compounds today. And of course, this is what we've got next time, starts the mole. So I want to go to the other handout that we started, which is this. So we're going to spend probably the rest of the time on this. So on this page right here, this is simply binary compounds on this page. You've got a single positive and a single negative. Notice that the second one is negative, and every one on this page ends in IDE, right? It ends in IDE. Now, yes, Wednesday, I said to you, I wrote these 8 up here, and I say, these are no-brainers. Because the reason I say they are no-brainers is the positive ion that I picked out here only has one possible positive charge, so you do not have to worry about Roman numerals. So you just look this up. Scandium oxide, magnesium nitride, magnesium chloride, magnesium oxide, sodium fluoride, strontium bromide. There is no Roman numerals there. Again, IDE, right? These are still binary compounds. Then we went to this. And this is where we left off. I want to stress this. When you're trying to figure out what the positive charge is, you're going to know what the negative charge is. As I go to my periodic table and I zoom in, let me stress to you, if I take nitride, that's plus and minus 3. The rest of these numbers are all positive. So what's the only negative charge nitride takes on? -3. We'll talk about this freakish thing. Oxide is -2, peroxide's -1. We'll talk about that. If I go down to phosphide, what is the only negative charge it takes on? -3. What's the only negative charge sulfur takes on? -2. So the negative here is only for one number. Chloride, -1. Bromide, -1. Selenide, -2. Arsenide, -3. Antimide, -3. Telluride, -2. Iodide, -1. Again, I'm going to say it again. There's only one negative, except for this. I'll tell you that. So if there's only one possible negative, that allows you to figure out what the positive charge is, right? If there's only one negative. So if we go to this one here where we left off, we have ruthenium selenide. Selenide, if we look it up on our pink sheet or right here, the only negative it can be is -2. So if I put a -2 here, and if you've got 4 of them, that gives us -8. So my ruthenium has to be +8. +8. So VIII. All right, the next one is the first time we've seen a polyatomic ion. I want to explain to you a polyatomic ion. This right here is sulfate. Sulfate. Let's take I'm going to explain polyatomic ions right here real quick. I hope. You have 1 sulfur and 4 oxides that stay covalently bonded together as one unit. They stay together as one unit. So you've got this. Sulfate has a charge of -2. So my oxides here, -2, -2, -2, -2. If the charge of my SO4 is -2, what is the charge of my sulfur? +6, right? Because +6 -8 leaves me my charge of sulfate of -2. So realize sulfate stays together. It has a charge of -2. What is that? It's 4 oxides with a sulfur 6. If I had sulfite, it's SO3 ion -2. Well, how do I get that? -2 on oxides, -2, -2. It's a +4 sulfur there. Is that right? This is sulfite, SO4 -2. Excuse me, this is sulfate, SO4 -2. This is sulfite, SO3 -2. It's no different than nitrate. Carbonate's in here, but nitrate is NO3. You're going to see nitrate is NO3 -1. How do we get that? We get that because we have a nitrogen with 3 oxides. What's the charge of oxide always? -2, -2, -2. Nitrate has a charge of -1. What's the charge of that nitrogen within nitrate? 5, right? +5. This is a +5 nitrogen there. In nitrite, it's +3. So again, you still have ion charges, but they stay bonded together as one unit. So this is tungsten sulfate. We can expand this one out like this. We have WW, SO4, SO4, SO4. We have 2 tungsten and 3 sulfates. What is my charge on my sulfates as one unit? As one unit. Every time I have a sulfate, -2, -2, -2. What's my total negative? -6. If my total negatives is -6, you know you have to have a +6 to get 0 for my compound. +3 and +3, right? So this is tungsten 3 sulfate. There we go. Tungsten 3 sulfate. This one right here, I have vanadium carbonate. Vanadium carbonate, but vanadium can have more than one possible positive charge. If we look up carbonate, well, we're going to start memorizing carbonate and sulfate. It is -2. Well, if I have 2 carbonates, that gives me a total negative of -4. So my vanadium is a 4, right? I have vanadium 4. And I could do this. And number 17, I have manganese nitrate. Manganese nitrate. The charge of nitrate is -1. I'm not going to write this out. I don't want to write 7 of them out. But if I have 7 nitrates, that gives me a total of -7, right? And I only have 1 manganese to get me the +7. So manganese nitrate. This is a 7. Manganese 7 nitrate. You're going to memorize nitrate. These are 3 good ones right off the chute, right out of them. We got sulfate, carbonate, nitrate. This CrO4 is chromate. So this is gold chromate. And this chromate is -2. We've got 3 of these. That gives us a -6. We know we're going to have +6. So these 2 golds would be +3. So this would be gold 3 chromate. Gold 3 chromate. All right. Again, these up here, no Roman numerals. Why not? Because the only charge silver can ever be is +1. The only charge lithium can ever be is +1. The only charge scandium can ever be is +3. The only charge magnesium can ever be is +2. So we're not going to use Roman numerals if it's only one possible positive charge. Down here, we have to use Roman numerals if the positive ion can have more than one possible positive charge. So let's turn the page. Now we're going to write out some compounds with polyatomic ions. By the way, here's a YouTube recording that I've done, and I've actually chopped it off that does this page, I think, and the next page maybe. Okay. So number one, we have sodium, and you could, this looks so complicated, but it's not. You could sound that out. Hexa cyanoferrate, right? Hexacyanoferrate, not bad. So we've got sodium. Let's write this thing out. We've got we're going to go below that. So we get sodium plus 1. Hexacyanoferrate is Fe, left parenthesis, Cn, right parenthesis 6, all connected. And hexacyanoferrate has a -4 charge as an ion, a -4 charge. So how many sodiums do I need total? I need 4 sodiums, right? So I'm going to drop a 4 right there. There is the formula for sodium hexacyanoferrate 2. You don't see Roman numerals here very often on a negative. All right, let's do the one number 3 here. We have calcium sulfate, calcium Ca plus 2, sulfate SO4 minus 2. I'm done, correct? That's it. I've got a +2, -2. I'm done. Let's box that one in. Mercury 2 oxide. Hg +2. Oxide is O -2. This is a binary compound. I'm done, right? Done? +2, -2, I'm done. All right, let's go to number 2. Carbon dioxide. Carbon is O, excuse me, carbon is C, oxide is O, di 2. Number 4, magnesium chloride. Magnesium, Mg +2. Chlorite. ClO2 -1. I need another chlorite, right? Because I got to get 0, so I'm going to have another chlorite. -1. Now I am happy because I have a +2 and I have a -2. I know I have this formula of this compound written correctly. And what I'm going to do for a final answer is this. I'm going to have Mg, left parenthesis, ClO2, right parenthesis, and I have 2 chlorates, right? Two chlorates. Now listen. Don't get all parenthesis happy on me now. Pretty soon, I just showed you parentheses for the first time writing the compound. And pretty soon, I got students go to the first page. Oh, I got parentheses, and they're going to take water, and they're going to write, oh, we're going to put parentheses around this, and we're going to write parentheses around this, parentheses around this. And pretty soon, they're all parenthesis happy, and all they've done is made a mess. This does us absolutely no good, right? This just creates a mess. When are you going to use parentheses? Not for any binary compounds. You're going to use parentheses when you have polyatomic ions, such as chlorite, chlorate, perchlorate, nitrate, and you need more than one of them. Because over here, I only needed 1 sulfate. I don't need parentheses. Over here, I need 2 chlorides. I need parentheses, and I need to indicate that I have 2 of them. Only use parentheses when you need to. How do you know for sure? Look up the answers in Canvas so you know you're writing these exactly. Don't just scan it, thumb it, one to make sure. Okay, let's do number 6. Number 6, very common for parentheses not to put in. We've got iron plus 3. We've got hydroxide. Hydroxide is OH, -1. We need 2 more hydroxides, yes? So we should have OH -1, OH -1. So what is my formula now? Fe OH3. Iron 3 hydroxide. All right, I'm going to show you a few freaks. Number 22, mercury 1 bisulfide. Mercury 1 and peroxide are 2 interesting ones. Let's do peroxide first. Peroxide is really this. There is 2 -1 oxides hooked together. So peroxide is always O2 -2. Peroxide is always O2 -2. That's why you see this -1 here. Again, this -1 is if you have a peroxide. So you're always going to see peroxide as O2 -2. What do you have? You've got 2 -1 oxides. And the other freakish one is mercury 1. Mercury 1 is 2 mercury 1s hooked together. They're both +1 mercuries. So if they're hooked together, you always have a 2 down here and it's +2. Mercury 1 is Hg2 with a +2. So peroxide, mercury 1. So I'm going to go down to 22. So in 22, if you have mercury 1 bisulfide, normally you'd think it would just be Hg with a +1, but again, mercury 1, Hg2 +2. If we look up bisulfide, HS -1. So we're going to need another HS -1. So we're going to end up with Hg2 HS2. Okay, let's see. That'll get you through this page. Look up the answers. Let's go to the next page. Page 4. Yes. You on the test, I let students use the pink sheet and I got yelled at. That's why I underlined this. So the answer is no. Yeah, I got yelled at. It's kind of like, my philosophy is, if you can look up the charges and write the compound, you should be able to do it. If it was my choice, I'd say, just use the pink sheet, right? I mean, it's 2023, right? You can get the charge on your phone in 2 seconds, as long as you can write down the correct formula, but I got yelled at for that. So that's why I had you highlight these. These are the ones, as we use them, you're gonna memorize these. So good question. Yep, I got yelled at. So, all right, this first one here. This is one we haven't talked about yet. If you look at everything that I've highlighted on here, and if I haven't highlighted mercury 1, which I did not, the only positive on here is ammonium. The only positive is ammonium. So out of all these that I've highlighted, they're all negative except for this one. And notice you'll see acetate written this way. A lot of times, the acetate that you're going to see is written like this in OWL, I believe. Most of the time it's written like that. So it can be written both ways. Okay, so the very first one then, I did NH4. There's your positive, and there's your negative. So NH4 is +1, fluoride is -1. We simply have ammonium fluoride. Now, here's how you want to attack these. I'm going to write down I'm just highlighting my positive ion here. You know you're going to have a positive and a negative, right? You know you're going to have a positive and a negative. Come on, focus. Hg is mercury. Do I need Roman numerals for mercury? I do. Cl is going to be chloride. Now, do I have mercury 1 or mercury 2? Well, I can't have mercury 1 because remember, mercury 1's Hg with a little 2 down below. You don't see the 2, so you automatically have mercury 2. Number 3, K is potassium. Do I need Roman numerals or parentheses? No, potassium's always +1. It's the only thing it could be. So this is bromine. Let's go to number 6. Then I'm going to backtrack a little bit. Number 6, Mn is manganese. Do I need Roman numerals? Absolutely, for sure, because it can be 2, 4, 2, 4, 6, 7. So I'll figure that out. Now you want to try to find ClO3 on your pink sheet. You should scan under your C's. See if you can find ClO3 alphabetized. See how your eyes work this Friday morning. ClO3. Do I have it highlighted? Is it one of our highlighted ones? It is, right? Whoops. ClO3 minus chlorate, yes? Try to scan. All right, so we know we have chlorate. What is the charge of chlorate? -1. I've got 2 chlorates. for -2. So I know my manganese is +2. Okay. Number 5. So that's how you want to do it. Start looking under the first letter for the negative ion. In number 5, you have sodium C2H3O2. If it's not under the C's, I have put the letter here of where to find it. Because you would never think as you scan and scan and scan, it would be the top one, because you would never would focus on the top one. And then you'd go stir crazy trying to find it on this sheet. So alphabetically, that's why you see a letter here by the number. So Na is sodium, and C2H3O2 is acetate. That is sodium acetate. Number 20, and then we got it. Number 20, I just want to show you real quick. When you see O2 without parentheses, you would assume it's oxide. -2, -2, +4. You would think this is chromium 4 oxide, but chromium 4 does not exist. There is no chromium 4. So this is chromium 2 peroxide. That's the only way for that to work. Chromium 2 peroxide. All right. We're still doing 1 through 13 on this. On the other quiz, though, on this other quiz, you're going to have lots of questions probably next time we meet. On this other quiz, don't leave your seats yet until you get this one down. There you go. For this quiz, try these. And then we'll finish this up on Monday. We'll finish this up. And then that means we're going to the mole on Monday as well, right? So you should be able to finish up chapter 2, part 1 by Sunday midnight. Where's that attendance sheet at?